Namaskar. Good evening, everyone. Welcome to our 83rd session of the Virasat Talk program being organized by the Intangible Cultural Heritage Department of Heritage Society, Patna. I request all our viewers and our followers to join our evening session as soon as possible. I also request you to share the live link to with your other colleagues and your partners so that we can reach out to more and more people. Today, we have a very important topic. Today, the topic of the session is Rouletted Ware, an introduction to its provenance and technology in early historic South Asia. And with us, we have today Dr. Louise Ford. She's an archaeological consultant and an independent researcher. I welcome you, ma'am, in our evening session. It's our distinct honor and privilege to see you here in our evening session of the Virasat Talk program. Dr. Louise Ford gained her PhD in South Asian archaeology at the University of Bradford under the supervision of Professor Robin Cunningham and Professor Mark Pollard, in which she undertook chemical analysis of rouletted ware. She has also studied with Professor K. Krishnan at MSU of Baroda, where she trained in ceramic petrography and ethnoarchaeology. Louise has lectured in South Asian archaeology at the University of Bradford and is currently an independent researcher and an archaeological consultant. Today, Madam will be speaking on rouletted wares, and this rouletted ware is such a distinctive type of ceramic, which in fact has a long history of its use in South Asia and in Southeast Asia as well. And today, Madam will be speaking on this, and this is also an opportunity for all heritage lovers and students like me to know in more detail about how this whole ceramic type has influenced the archaeological history of this whole region. So I will not take much time, and I will request Madam Speaker, Dr. Louise Ford, to kindly begin the session. Thank you, ma'am.
Thank you, Azad. Let me share the screen. Right. Can you see the screen?
Yes, ma'am. We are able to see your PowerPoint.
Okay, brilliant. Right, I'll make a start then. So thank you to Dr. Duvey of the Heritage Society of Bihar for inviting me to lecture today as part of the Archaeological Exploration and Excavation Department within the Virasat Talk series. Thank you also to Azad for his kind introduction just now and for his technical support. So today I'm going to talk about rouletted ware, which is a commonly found ceramic on early historic sites with a wide distribution extending from Ayodhya in the north to Tisamaharama in the south in Sri Lanka, and east to Sembiran and Pakung in Bali in Indonesia, and west to Berenike in Egypt. It was first discovered by Sir Mortimer Wheeler during his excavations at Archaeological in 1945, who suggested it was a Roman import. Research over the past years or so has contributed to our understanding of this ware, and it is now known to be of South Asian origin and comprises part of a suite of ceramics known as fine grey pottery. So this is the suite of ceramics of fine grey pottery, and it comprises rouletted ware, plain grey ware, Archaeological type 10, knobbed ware, Archaeological type 18, and Archaeological type 141. The Archaeological types were also first recorded by Wheeler at Archaeological, whilst knobbed ware was first documented at Sisupalgarh during B.B. Lal's excavations and is frequently found at sites in Odisha. They all have distinctive decorative features. So with rouletted ware, we have the distinctive chattered decoration. Plain grey ware is generally plain, as the name suggests. Archaeological type 10 has the distinctive stamped peacocks. Knobbed ware has this internal boss and is generally has these concentric circles. Archaeological type 18 generally has a carination and also the incised lines on the exterior. And Archaeological type 141 is distinctive for its etched design of lotus flowers. Rouletted ware, however, has dominated research due to its higher quantities, wider distribution, and recognisable features such as the beaked rim and chattered decoration. Vimola Begley's research on the decoration of rouletted ware has confirmed that the design is actually a technique known as chattering rather than rouletting, where incisions are applied by bouncing a tool on the pot surface whilst the vessel is rotating on a wheel. Joe Shoebridge's research on the decoration of Archaeological type 10 has confirmed that only peacocks are present and not any other creatures. Following Hydron Schenk's work at Tisamaharama and Robin Conningham's excavations at Anuradhapura, both sites in Sri Lanka, grey ware can now be dated from around 500 BCE, whereas rouletted ware, type 18, type 141 and knobbed ware date from around 300 BCE, and Archaeological type 10 dates from around 200 BCE. Hydron Schenk's work at Tisamaharama identified that the production ceased in the 1st century BCE, although the radiocarbon dated sequence at Anuradhapura suggests more of a 1st century CE date. It is therefore a very useful chronological marker for early historic sites. Its distribution demonstrates that it was traded extensively during this period, and as such, it is a very valuable ceramic category to understand more about the dynamics and mechanisms of Indian Ocean trade. As an elite ware that probably functioned as tableware, it can also provide us with insights into the wider themes of craft specialisation, organisation of ceramic production, and the development of complex societies. So it is a very useful pottery type that needs to be understood further. The vast majority of research into these ceramics since their discovery has concentrated on provenance studies. Wheeler's original claims that rouletted ware was of Roman import have now been discredited through more recent research, and an origin in South Asia is now agreed amongst scholars. However, the exact location of its production remains elusive, with some researchers arguing for a North Indian origin, whilst others suggest South India or Sri Lanka. To tackle this problem, there have been a number of chemical analyses over the past 30 years or so in an attempt to provenance rouletted ware, but these have not been without difficulties, such as the types of analyses undertaken and sampling issues, and we still do not know conclusively where these ceramics were originally produced. So 7 different chemical analyses have been undertaken since the 1980s using predominantly X-ray diffraction. So these 4 have all used X-ray diffraction, or rather 5, because Gupta included 2 different studies. Of these, we can see that Ardagher et al. Also used neutron activation analysis. Das et al. In 2002 complemented their study with XRD by using scanning electron microscope, differential thermal analysis, stroke thermogravimetry analysis, as well as energy dispersive analysis of X-ray. My own study included inductively coupled plasma atomic emission spectroscopy, as well as inductively coupled plasma mass spectroscopy. And finally, Das et al.'s most recent work involved wavelength dispersive X-ray fluorescence spectroscopy. Whilst all agree on a South Asian origin, the location proposals are diverse, with West Bengal, Andhra Pradesh and Tamil Nadu posited. So if we look at the geological map of India, we can see the yellow colour here that starts in South India here, runs along the east coast up into Bengal and into North India. Now this yellow colour represents recent alluvium, okay, which is the result of weathered rocks, and it shows the similarities in geology between both the north and the south, and indeed along the east coast, making it very difficult to distinguish between the regions. Combined with the ambiguities of the chemical analyses and the geology, there are two other major problems with provenance in rouletted ware, which have also hindered these studies. Firstly, the clay paste preparation techniques used to manufacture rouletted ware are complex and include a process known as levigation. This was used to prepare a fine clay by essentially washing the clay, whereby the lighter minerals rise and the heavier fall, and it is the lighter, finer clay that is used to make the pottery. These lighter minerals predominantly comprise mica, quartz, and feldspar. This limited range of minerals are widespread within clays and rocks and are not distinctive enough to identify a geological area using techniques such as thin section analysis. Other techniques may also have been used to prepare the clay, which are very difficult to detect, such as tempering and mixing of clays. All these clay paste preparation techniques can have an effect on the chemical composition, potentially causing problems when interpreting geochemical data. Secondly, there is a lack of archaeological evidence for pottery production, such as kilns, wasters, workshops, tools, etc., at early historic sites, which is another stumbling block in our search for provenance that requires further research to understand this lack of evidence. And I will discuss this a bit more later on. So previous attempts to provenance rouletted ware using geochemical and petrographic techniques have been problematic, meaning that we still do not know the exact location of its original production. And we need to be open-minded about this until further evidence is forthcoming. Likewise, we need to be critical of our interpretations of the existing chemical data. We do know that rouletted ware and associated wares are South Asian in origin and not a Roman import, as they predate trade with Rome. However, there are convincing archaeological arguments for both North and South Indian origins. The evidence for a North Indian origin is highlighted by similarities between the fabrics of northern black polished ware and fine grey pottery. However, these similarities have only been witnessed through macroscopic observation of the sherds and limited chemical analysis using XRD by Gupta, in which only one or two samples of northern black polished ware were analysed, which is not enough to be conclusive. No studies directly comparing the two wares has been completed to assess this fully, and this needs to be undertaken in the future to explore this further. Schenk has also uncovered evidence of northern black polished ware sherds with chattered decoration at Tissa Maharama in context preceding rouletted ware. This is supported by Colleen Lefranc's research at Mahastanagar in Bangladesh, who asserts that rouletted ware is an evolution of northern black polished ware and part of a fine black slipped ware tradition that is common across Bengal. Clearly, there was a fashion for black slipped grey wares during the early historic period, and also much earlier, with the dating of northern black polished ware now extending back to around 800 BCE. Northern black polished ware also has the distinctive tali dish shape like rouletted ware, but without a beaked rim and no distinctive decorative features that are characteristic of the fine grey pottery suite, apart from these few sherds found at Tissa Maharama. However, there is a noticeable lack of rouletted ware at key sites in the Ganges Valley, such as Pataliputra, and only two sherds each at Rajghat and Ayodhya. At Chandraketagar, no report has been published, no final report, and only profuse quantities has been published, which we have no idea how much that means. Mahastanagar, the 79 sherds there are from the Mazar region of excavations, and so this number is likely to be a little bit low, but even so, it is probably only in the hundreds. And if we compare that to the South Indian and Sri Lankan sites, we literally have thousands. We have tens of thousands at Archaeological, 13,000 so far at Patnam, and the excavations are still ongoing there, around 4,000 at Tissa Maharama, and over 1,200 just within one trench at Anuradhapura. Adapora. So again, that figure is on the low side, and far more sherds than this have actually been found. We also have the evidence of the grey ware found at Adapora that dates back to around the 5th century BCE, and it has a clear taliform and beaked rim, suggesting it is a precursor to the rouletted ware. This is confirmed by petrographic and chemical analysis that demonstrate a compositional relationship with rouletted ware as well. The inverted firing technique that is diagnostic of the Iron Age black and red ware that predominates in the south also continues with rouletted ware, although we do get examples of vessels that are fired all black or all red as well. So we are seeing a continuity of traditions of the firing, the beaked rim and tali shape from the 5th century BCE in the south before the emergence of rouletted ware. Evidence for a South Indian origin is also attested by Jo Shoebridge's research, PhD research, which was published in 2017 and is available online. And she analysed the decoration of both rouletted ware and Archaeological Type 10 and suggested a South Indian origin based on the theory that a wider variety of decoration is expected to occur close to the point of production, and that sites in Southeast India, particularly Archaeological, show this to be the case. These variations are likely to be as a result of inter- and/or intra-workshop variability, or possibly consumer demand. Shoebridge's thesis has also demonstrated a lack of standardisation in the designs, along with regional differences. Features such as raised lines found on rouletted ware have been interpreted as guidelines, perhaps used by potters learning the chattering technique. These have been found at a number of locations, but they are more prominent in South India. It may suggest that this pottery was originally produced in South India, but over time it may have been produced in other locations, which would explain the regional differences, or that consumers demanded different designs in the various regions. We therefore have good archaeological evidence for both northern and southern origins. So turning now to the technology of rouletted ware, we can explore the concept of chaîne opératoire. This is a frequently used term to help understand the technological processes of pottery production. It is a term first coined by the French anthropologist and archaeologist André Leroy-Gohan over 50 years ago, but many archaeologists are now using this technique to apply to ceramics. Chaîne opératoire can be defined as the description of the whole manufacturing process and involves the series of operations that transform the raw material, as in the clay, into the finished product, i.e. the vessel. So according to Valentine Roux, who is also an expert on chaîne opératoire, an assemblage should first be sorted by technical groups, such as whether they were wheel-made or handmade or coil-made, etc. Secondly, these groups should be refined by technopetrographic groups, that is, using the fabrics to discern any differences or similarities between the technical groups. And this can be done on site using macroscopic observation with a hand lens, and then can be followed later in the laboratory using thin section analysis. The third stage of sorting should include technomorphological and stylistic groups, as in the vessel forms, so that we can begin to assess the function of the vessels. Recent studies by Colleen Lafranc and Jason Hawkes have successfully used this method to aid their analysis of the ceramic assemblage at Mahajari in Maharashtra. They have published open access articles to develop the use of this technique in South Asian ceramics, following the methodology laid down by Valentine Roux. This methodology is used for the initial classification of pottery on site and is a very useful and informative approach. We can also apply this method to analyse particular types of pottery, such as rouletted ware, to discern more information about each of the technological processes used for its production. So the stages of chaîne opératoire include the collection of raw materials, preparation of those raw materials, forming, finishing, drying, decoration, surface treatments, and firing. It is not without difficulties in that each stage introduces new characteristics that can destroy previous treatments. The surface features are polysemic, which means that the same features can be obtained by different techniques. This makes it very difficult to ascertain the true manufacturing process precisely, and it is therefore best to use a variety of techniques to investigate the manufacturing technology, including macroscopic analysis, thin section photography, as well as ethnoarchaeology. So we can use this model to apply to rouletted ware in order to help us to understand this pottery further and the processes involved in its manufacture. So I've used both macroscopic examination and thin section photography to analyse the fabrics, forms, surface treatments, decoration and firing to reveal insights into the technology. And I've used the radiocarbon dated sequence at Trench ASW2 at Anuradhapura in Sri Lanka. In total, I analysed 85 sherds by thin section photography, which included rouletted ware, grey ware, Archaeological type 10, Archaeological type 18, omphallous ware, as well as coarse wares. Omphallous ware, just in case you're not aware what this is, it's a type of knobbed ware that is found in Sri Lanka and South India, and also Thailand, and it differs to knobbed ware in that it has a ringed or foot ring base and generally doesn't have the concentric circles. So I've also looked at other sites as well with these same sherds, including Archaeological, Alaganakulam and Vadamanu in India, as well as the Sri Lankan sites of Kantarodai and Mantai. In total, I analysed 136 sherds macroscopically, including all of these ceramics, but I will concentrate just on assessing the technology of just rouletted ware, which was 69 sherds through macroscopic observation and 43 sherds by thin section photography. And this data is supplemented by ethnoarchaeological evidence. So, whilst we do not know the precise location of where the clay was collected for rouletted ware, as we've discussed earlier with looking at provenancing, we do have an understanding of how the clay was prepared. Various techniques are used to prepare clay, including picking out large particles by hand, drying the clay, then crushing and grinding it, and sieving it. Another process is levigation that I mentioned earlier, which is also known as elutriation, where the clay is mixed with water and the coarser particles settle out of the suspension. The fine clay on the surface is then used to make the vessels. The clay can also be modified through tempering, where something is added to the clay to make it more workable. This can include vegetation, such as dung, shells, or other minerals, such as quartz, or even another clay. If the clay is not already wet, water is added to it to make it plastic, and then the clay is wedged by kneading with hands and or feet, followed by cutting and hitting on a hard surface. This allows for an even distribution of moisture and inclusions, as well as eliminating air pockets and to ensure a smooth paste. The clay is then often left to age or sour for hours, weeks, or months, depending on the individual potter and their preferences. As witnessed by macroscopic observation, rouletted ware is very fine grained, and therefore the clay must have been prepared to remove large inclusions and any waste materials, such as vegetation, that may have been naturally present in the clay source. From the petrographic analysis that we can see here, so this is a thin section of rouletted ware, we can hypothesize that the clay was levigated due to the lack of heavy minerals and the fineness of the ceramics. It is uncertain whether it had undergone any other processes prior to this, such as sieving or mixing of clays, as this is difficult to identify. It is possible that the clay was tempered, as there are some quartz grains that are angular to subangular in shape. If you can just see the tiny white specks, some of these can be quite angular and subangular in shape. And this may suggest that they were added as temper, but this can be difficult to interpret, particularly in fine wares. The addition of quartz is actually a very common temper, as it helps to avoid cracking during firing and is often added to fine-grained clays because they are lacking in minerals. Moving on to forming techniques, 3 categories of forming are discernible, including continuous rotation on a wheel, interrupted rotation on a turntable, and static forming, such as hand building, coiling, and moulding. Some vessels are produced using multiple methods, which can make it difficult to identify with certainty. So, for example, a pot that has been coil made can then later be turned on a wheel afterwards to neaten it up. And so it's those kind of processes that can be difficult to discern. It's likely that rouletted ware was mould made, as there are too many variations in the sizes and rim shapes and no macroscopic evidence. We would expect to see rilling if rouletted ware was coil built, and there is no evidence for this or for hand building. It is therefore postulated that rouletted ware was wheel thrown. So whilst this isn't 100% clear macroscopically, it is discernible microscopically with the evidence of a strong alignment of the minerals. And in particular, if we look at the mica, which are the long elongated inclusions that you can just make out a few of them in here, but also you can see the larger inclusions of quartz as well, and they're all generally aligned in one particular direction, and this is due to fast rotation on a wheel. The matrix is also densely packed with very few voids, which is also suggestive of wheel throwing. Colleen Lefranc and Jason Hawkes' recent research in Maharashtra have identified the presence of a horizontal line just below the rim on some of the sherds, which shows a slight thickness, leading to the suggestion that the rim was added as a separate coil and then finished on a slow wheel. This has also been observed on sherds from Thailand and Myanmar by Colleen Lefranc as well, but it is not present on all sherds. Whilst this has not been detected either in thin section or macroscopic analysis of sherds from Anuradhapura, it is certainly an interesting technological question that requires further research. Now, the shape of rouletted ware is a distinctive Thali dish shape and is often accompanied by a distinctive beaked rim, although other rim shapes are identifiable. At Anuradhapura, 4 different rim shapes are known, which include plain round edge rims, which is very similar to the Northern Black polished ware rims, beaked rim, undercut rims, and beaked rim with lip on the internal edge, such as these ones. 10 forms were identified by Wheeler at Archaeological, whereas Hydra and Schenk has determined 3 separate forms at Tissamaharama. However, she's identified Wheeler's type 1H, this one, which is more of a bowl form and is a bit smaller as well, and she has identified that as a separate form at Tissamaharama. Finishing techniques can include beating or paddling, scraping, trimming, smoothing, burnishing, and polishing. Paddling and scraping are more often used with coil-built ceramics and were not used here. Trimming is often undertaken on wheel-thrown vessels in a leather-hard state to trim off any excess clay or imperfections. Smoothing is done with a cloth or even the potter's hand and is normally carried out before it is completely dry, or maybe re-wet in order to do this. Burnishing is when the surface is rubbed by a hard object, such as a pebble or a bone, to create a very smooth surface and provide a lustre, and is undertaken on leather hard or dry clay. Finally, polishing differs to smoothing or burnishing in that it involves rubbing a dry surface with a soft material, such as a cloth, and gives a uniform lustre. Whilst it is uncertain which techniques were applied to rouletted ware, as these are the sorts of methods that are very difficult to identify and only really understood due to ethnoarchaeological evidence and some macroscopic evidence as well, we can surmise that trimming was a logical procedure to get rid of any excess clay, and either smoothing or polishing was performed using a soft material, either whilst the clay was still wet or leather hard, or polished once it was completely dry. As these ceramics are very fine and often with thin walls, the more rigorous burnishing technique is unlikely to have been applied. Once the vessel has been constructed, it has to be left to dry, and this can be done inside or outside depending on the space available and the weather conditions. If any moisture is left in the vessel, it will likely damage the pot during firing, so it is an important process. As the vessels dry, they shrink in size, although the amount they shrink is dependent on the clay used. Certain clays, such as Montmorillonite, shrink more than other clays, which can cause cracking during firing, and this is why it is sometimes necessary to add temper to the clay. Drying can take longer during damp weather, and it is best undertaken when it is dry and hot, and therefore some potters prefer to only manufacture vessels seasonally, such as during the hot months. However, some potters use drying facilities, such as kilns or ovens, in order to counteract adverse climatic conditions and speed up the process. It is also difficult to identify archaeologically, and this process can only really be observed by assessing modern potters. Often vessels undergo further surface treatments and/or decoration once they are dried to a leather hard state, which is what we see with the rouletted ware. So the decoration on rouletted ware is distinctive and was originally believed by Wheeler to be as a result of rouletting, hence the name. Rouletting can be defined as the process of making indented concentric or spiral linear patterns on pottery by means of a small-toothed wheel called a roulette. The patterns are produced by the continuous rolling motion of the roulette when it is held against the revolving clay vessel. However, Begley's ethnoarchaeological research at Bijnour near Lucknow has demonstrated that chattering is more likely to have been the technique used rather than rouletting. Shattered designs are also arranged in concentric or spiral bands made of tiny wedged-shaped indentations and are produced by the continuous flicking motion of a tool with one or more long, thin points when it is held against the surface of the clay vessel, rotating on the potter's wheel. The potters at Bijnour used a wooden tool, a bit like a stylus, to produce the chattered design. Both techniques were used in the Mediterranean world, with Greek vessels often chattered and Roman ones rouletted, and Begley has suggested that this decoration was inspired by contacts with the West. On rouletted ware, the pattern generally includes 1 to 3 bands of concentric circles, with each band comprising around 3 to 10 rows of indentations that appear as dots, triangles, wedges, lines, etc. The vessel is normally dried to a leather hard state before decoration is applied, as if the vessel is still wet, the pattern would be more gouged in appearance. The hypothesis of a wheel-thrown forming technique, as discussed previously, is further strengthened by this decoration, which can only be applied whilst rotating on a wheel. Numerous surface finishes can be applied to pottery vessels to add colour and reduce permeability, and include slips, washes, and glazes. A slip is a fluid suspension of clay in water applied to form a thin, non-vitreous coating on a vessel. It is applied to the vessel before firing, whereas a wash consists of the same substance but applied after firing. Glazes are typically high-fired and vitreous and compositionally more complex than slips or washes. So petrographic analysis has confirmed the presence of one slip. So if you can just see this line, this very thin line at the top here, this is the slip, and it is compositionally the same as the rest of the vessel, but it is watered down, and so we can see that that has been applied to the rouletted ware surface. We can also see from the rouletted ware sherds that the slip must have been applied following the application of the decoration, as the slip is present within the indentations. It is likely that this slip was applied through dipping the vessel into the slip, but it could also have been wiped on using a cloth or a brush. Wiping tends to give an uneven coverage though, and could have also destroyed the chatter design, so dipping appears to be more logical. There are two types of firing, those that with separate fuel and pottery and those that are intermingled. Mixed firing is most commonly observed with bonfires, also known as open firing, as well as semi-subterranean structures such as pits. It involves a bed of fuel laid on the ground, then the pottery is placed over the top and more fuel is placed around and on top of the vessels. The fuel can vary depending on what is locally available and can comprise agricultural products, wood, bark, coconut husks, and dung. Dung is particularly used in South Asia, as indicated by ethnoarchaeological evidence, and is proven to be a very effective fuel. Dry dung cakes are porous and burn at a steady rate, which means that if it surrounds the pottery, it allows the vessels to be fired in oxidizing conditions. It also does not produce much carbon, therefore reducing smudging that can occur with wood. Dung ash also acts as an insulator, preventing fluctuations in temperature that would normally occur in open firing, causing the pottery to shatter. The ash can also create a reducing atmosphere if required. This therefore allows for better control of the firing temperature and atmosphere using open or pit firing methods which have previously been considered to have less control than kiln firing. Dung is therefore a particularly efficient fuel for impermanent firing structures. Kilns tend to separate the fuel from the pottery and are partly or completely closed structures. They contain a firebox or mouth to burn fuel and generate heat, a chamber to hold the pottery and to retain heat, and one or more flues to allow hot gases to escape and to create a draft to move the heat from the firebox to the chamber. Kilns permit better control of the temperature and atmosphere, particularly the rate of heating. Two types of kiln are identifiable, an updraft kiln and a downdraft kiln. So updraft kilns are enclosed chambers in which the heat moves upwards from underneath the pots and is vented outwards. A perforated platform of clay or brick acts as a floor to the chamber to allow the heat to penetrate into the chamber from the firebox. The heat and gases escape via a chimney in the roof, and they are often circular in shape. A disadvantage of updraft kilns is that hotspots are created, so parts of the load may be overfired and other parts underfired, and those at the base closest to the fire may suffer from thermal shock. Downdraft kilns also have a firebox, but the flues direct the gases upwards over a bag wall. So this section here, this is the bag wall. So the gases are directed upwards and then they are deflected downwards from the top of the kiln through the pottery to exit flues near the bottom of the chamber and then up through into the chimney. These types of kilns discourage the hot spots encountered in updraft kilns. Ovens are less complex than kilns and can be either permanent or impermanent structures. There is thought to be less control over the draft or fuel consumption, but they do generally conserve heat better than open firing. As no evidence for pottery production has been identified at early historic sites, we do not know which technique was used to fire rouletted ware. This lack of evidence points to a more impermanent structure, but this could still include open oven, pit, or kiln firing. Ethnoarchaeological evidence has suggested that modern potters in South India and Peninsular India prefer to use oven firing, whereas those in North India practice kiln firing with sporadic oven firing. For rouletted ware, we can estimate a firing temperature of around 700 to 900 degrees C, as indicated by petrographic analysis, based on the presence of unaltered muscovite mica and the optical activity of the ground mass. So here is a piece of muscovite mica. There are a few other inclusions dotted about, but you can just see this piece here, which is particularly clear, and this is muscovite mica, and it has not been altered by the firing process. So muscovite mica tends to alter at temperatures above around 900 degrees C. So we can say that this pottery was not fired above 900 degrees C. Samples with an optically active matrix. So what that means is when we look at pottery under cross-polarized light, and when we rotate the stage, sometimes the ground mass, the matrix, can change color. So here is one section, and then this is it when it's been when the stage has been rotated, and we can see a slight change in color, and that suggests that the matrix is optically active. Okay, so if we have an optically active matrix, we are likely to have temperatures fired below around 800 to 850 degrees C. If the matrix is inactive, as in it does not change color when the stage is rotated, that suggests that the temperature was fired above around 800 to 850 degrees C. Now, the thin sections of rouletted ware show both active and inactive ground masses, suggesting we have a range of around 700 to 900 degrees C. Now, these temperatures cannot help assign the firing method, as all of the different firing techniques can reach these temperatures. As rouletted ware exhibits a range of colours, including all red, all black, and some with both, it indicates that there were variations in the oxidation levels. The all black vessels were fired in reducing conditions, whilst the all red were oxidised. Those with both black and red surfaces indicate that a process called inverted firing was applied, in which part of the vessels were covered to provide a reducing atmosphere and create a black colour, whilst the rest of the vessel was exposed to oxygen. So the sherds from Anuradhapura were fired under reducing conditions, as represented by a grey core. You can just see the edges here, and you can see the grey core. And the vast majority were fired black on both sides, with only 3 displaying signs of inverted firing. The sherds from Archaeological again were also fired in reducing conditions, although about half have evidence of inverted firing. Sherds from Alaganakulum, Vadamanu and Mantai reveal reducing conditions as well as inverted firing, whereas one sherd from Kantarodai suggests oxidized firing conditions, although with inverted firing present as well. So the technology of rouletted ware and its associated ceramics in the fine grey pottery suite can aid our understanding of wider themes in archaeology, in particular issues of craft specialisation, standardisation and organisation of ceramic production. Whilst macroscopic observation of sherds is useful, more data can be yielded when combined with other analytical methods, for example, thin section petrography. The chain operatoire technique is a useful model to assess a ceramic assemblage on site in the first instance, and also to a particular class of pottery, as exemplified here. We could use ethnoarchaeology to help understand the technological processes, as well as for the identification of pottery workshops. As I discussed earlier, it is possible that an impermanent structure was used to fire these ceramics. We've seen that oven firing, a commonly used technique in South India, can include impermanent structures. Other indicators for ceramic production include stores of clay, fuel, tempering materials, tools, unfinished artefacts, and pottery wasters. Of these, the most reliable evidence comprises stores of clay, specific tools like stamps, wheels and wheel bearings, clay lumps, and overfired vessels. However, clay scraps and malformed vessels may not be recovered archaeologically, as these are returned to the clay heap for future use. Stores of fuel, pigments, or tools may have been used for other purposes and not specifically for ceramic production. Firing facilities may have been used for another craft, and only broken sherds or vitrified pottery will help discern this. Broken sherds are often used by potters to repair house walls and are also reused as tools within the household, such as ladles or scoops, and this evidence may be used to indicate the presence of potters. So looking to the future, more work needs to be undertaken to ascertain the provenance of rouletted ware and needs to include the analyses of clay sources in North and South India and Sri Lanka. These can then be compared both chemically and petrographically with rouletted ware. Ethnoarchaeology is a vital resource that should be used in association with scientific techniques to explore issues such as the location of clay sources and workshops, as well as firing and clay paste preparation techniques. Whilst most potters exploit locally available clay sources, it is not unusual for raw materials to be imported from some distance, as witnessed by ethnoarchaeological examples in India and Egypt. These clays may have been used to produce a particular type of vessel or ware, and it is possible that clay was transported for the production of rouletted ware. A particular hindrance to the provenancing of rouletted ware and fine grey pottery is the lack of evidence for pottery production at archaeological sites. It is possible that workshops were located on the outskirts of urban centres in order to be closer to resources such as clay and water, and also due to smoke production during firing. Whilst other craft activities such as metalworking have been identified within urban centres such as Anuradhapura, pottery manufacture has not, and exploration in the peripheral zones may be more fruitful. However, it must be borne in mind that traditional kilns are often impermanent and therefore difficult to trace in the archaeological record, and that potters often recycle and reuse wasters and broken pots. This may explain why we have not recovered any evidence so far, and it is something we need to investigate further. Samples taken from modern potters who use similar clay paste preparation techniques can also be compared petrographically and chemically with rouletted ware. So, to conclude, this lecture has introduced rouletted ware, a key early historic ceramic that acts as a chronological marker to relatively date archaeological contexts. Its wide distribution across South, Southeast and West Asia demonstrates its importance in Indian Ocean trade networks at this time. However, understanding these networks is hindered by a significant lacuna in our knowledge, the provenance of rouletted ware. Whilst chemical analyses have been insightful, they have not yet provided conclusive evidence for an origin, and further research needs to be undertaken to ascertain this problem. The chemical analyses suggest that a single geological origin in South Asia can be concluded. Thin section petrography cannot provide a geological source due to a lack of diagnostic minerals in rouletted ware, but it is a very useful technique to determine technological processes in addition to other methods, such as microscopic examination of the sherds. By analysing each of the processes involved in the ceramic manufacturing cycle using the Shane operatoire model, we have a more nuanced understanding of how rouletted ware was produced. Questions do still remain unanswered, however, such as which clay paste preparation and firing techniques were utilised, and further research is required. It should also be borne in mind that there are variations within rouletted ware found across sites in terms of their fabrics, forms, decorations, etc., such as the so-called imitation rouletted ware, which are not yet fully understood and reflect technological differences. Future work should be directed towards investigating this diversity in order to provide insights into wider themes such as ceramic specialisation and organisation of production within early historic South Asia. Thank you for listening.
Thank you, ma'am. Thank you, ma'am, for the very interesting lecture and for sharing your research. Thank you also for highlighting in such a detail about the rouletted wares and its distribution over the larger South Asia and Southeast Asia, along with the firing technology and all other details. So thank you, ma'am, for the very interesting lecture. We have received a small question from Sridharan Krishnappa. He's asking how do they maintain temperature during the firing technique?
Iron process. Okay, that's a really good question because it depends on what firing method is being used. So obviously in a kiln, it is easier to maintain temperature um, because you generally have more control over it. With it being generally an enclosed structure, you can control the temperature in that way. Obviously, open firing, you have a lot less control, and that's the difference between the different firing techniques, is this control with the temperature and also firing conditions as well. So I'm not a potter. I've never used a kiln, so I don't precisely know how they do control the temperature as such. But certainly, the fuel is very, very important, and dung that we know is used particularly extensively in South Asia is the perfect fuel to use because that does help maintain and control the temperature. So yes, there's a lot of variations involved in maintaining the temperature, and it's more to do with which technique was used. So does that answer the question? Does that help a little bit?
Thank you, ma'am. If you allow me, then we have one or two more questions from our
Okay.
curious audience.
Okay.
So there is another question. There is another question from Mohan Ramesh ji. He's asking: Type one rouletted ware is a fine ware. In the
Yeah.
earlier periods, locally made wares also have a similar design and shape as rouletted ware, but they are not fine ware. Can we call these locally made wares as rouletted wares?
So this is a really good question. It's quite tricky, really, because as I mentioned at the end there, we have these so-called imitation wares, and no one actually has done any research on the imitation wares. So we have a very poor understanding of these locally or potentially locally produced wares or imitation wares, because it's very difficult to define what they are because we don't really know because no one's done any research on them. So that's what we need to do for the future, is actually look at some of these potentially locally produced wares at each of the sites and see whether they were actually locally produced, whether they are actually connected to the next. So I've analysed two shirts from Copal, which were clearly of this imitation rouletted ware, and they look to have been locally produced within the Copal area, so in Karnataka, but yet have this imitation rouletted ware that isn't like the decoration that you normally find, say, at Archaeological, and the fabric was also a lot coarser and geochemically, it varied completely to the other fine wares. So a lot of the fine wares are incredibly homogeneous. I've not shown any pictures of my chemical analysis in this talk because it was just going off onto getting too long. But the sort of coarser imitation wares from Copal are chemically completely different, petrographically they're completely different, and visually, microscopically, they're also completely different. So there is definitely something else going on in terms of some other locally produced imitation wares, but we don't quite fully understand what is going on. And probably we are getting imitations at various different sites all across South Asia. Interestingly, we don't seem to find any of these imitation wares at Anuradhapura. We don't have any of those. We just get the fine wares there. So there is definitely scope for more research into that, hugely. So it is a really important aspect.
Thank you, ma'am. There are three more questions.
Okay.
Uh, Mohan Ramesh Ji is asking one more.
Yeah.
Another question is, could you please throw some light on the concave designs on seals found on the inner side of Rouletted Ware pottery, which has been found at Arikmedu?
What, I don't know what he means by that. Concave designs on seals. I don't know. Does he mean the chattered decoration?
Um,
That
I
is that what he means? It's just the word seals is throwing me off a bit. I'm not quite sure. I think he's actually talking about the rouletted designs. Um, So, as I mentioned in the lecture, there is a quite diverse range of designs of rouletted ware. And if you look at Joe Shoebridge's PhD thesis, so that is available online. If you type in Joe Shoebridge thesis, Durham University, it'll pop up. And she's written a whole thesis all about the decoration on rouletted ware, also Archimedes type 10. Get some more information about the different designs. So what she has found is that there does appear to be regional differences in the different regions. So she's looked at rouletted ware from South India, from Sri Lanka, from North India. I think that she may have even looked at Southeast Asia as well. I'm not quite sure. So there is a huge variety of designs, and there does appear to be regional patterns as well. And she was also able to link up certain sites with other sites. So, for example, Arikamedu has clear links with Pukao Tong in Thailand. So we know that there is a clear link between the designs in different regions. So the decoration is actually very insightful in terms of looking at trade networks as well. So I'm not sure whether I've answered your question there, but I think it was to do with the decoration, or it might have been the technology of how it was produced. I'm not quite sure. So the there's obviously the chattered design, which has been suggested by Begley, appears to be more consistent with rouletted ware than rouletting. And again, I think Jo Shoebridge might discuss that in her thesis as well. So yeah, that might have answered your question. We'll see.
Ajay Kumar ji is asking any correlation between coated ware as to function or distribution can be linked to rolleted ware as they are chronologically found in same context.
As to function or distribution, so russet coated ware doesn't tend to have as wide a distribution as rouletted ware. It tends to remain in South India, although feel free to correct me if I'm wrong on that. I'm not an expert on russet coated ware. So in terms of distribution, it doesn't have as wide a distribution as rouletted ware. It doesn't appear to be, and it does appear to be quite a South Indian Peninsula Indian type of pot. I'm not sure on the function of coated painted ware, but quite possibly I think you do get dishes as well. So fine grade pottery is quite interesting because you get the range of forms. So with rouletted ware you get the dishes, whereas type 10 are more bowl shaped, and you also get sort of a more of a plate and dish shape with the type 141. So we've got quite a range of forms, and also the knobbed ware is bowl as well. And again, I think russet coated ware, I think you do get those different forms as well, dishes and bowls. So it's quite likely that they were also some kind of tableware as well. We're not quite sure. The function of sort of fine grade pottery suite, we assume it is tableware, but it can be found in contexts in Southeast Asia which are quite interesting. So, for example, in Bali, at Sembiran and Pakuk, they've been found within burial contexts. So that suggests, perhaps a slightly different significance to the pottery. which may just regional. It may be just that in Bali, there is some kind of symbolic nature to this pottery. Whereas in South Asia, we've not found any rouletted ware or any fine grained pottery in any kind of burial or ritual context. It's just been urban context, in occupational debris context. It's not in any kind of special context, whereas we're seeing more special contexts in Southeast Asia. So we're seeing some regional patterns of use and significance of that ware, and how that relates to russet coated painted ware. Well, russet coated painted ware isn't turning up in Southeast Asia, and I'm not sure, is it found in burial context? Because I know black and red ware does burial context in South Asia. So it's not directly related to it, but it's obviously something similar and a similar pot. But I've not specifically analysed any russet coated painted, so I don't know whether it's related microscopically or chemically, because no one's done any analysis on it. But it would be interesting to find out more about that and actually the relationships between them, if there is any kind of relationship. Yes, great question.
And there is a question from Saika Praveen. She is a research scholar. That, Madam, is there any evidence of cultural significance of design difference and colors used in pottery?
Oh, interesting question. So I'm not sure whether there's potentially cultural significance in the design, different designs, different colours, because we are seeing regional variations in the designs, and also to a certain extent with the colours as well, because certainly North India, sort of around Chandraghettakar, that area, the designs are very different to the designs in the south. So perhaps, does that mean they're being locally produced? Is there some, like you say, some kind of cultural significance to that? Are the consumers in North India, are they producing pottery up there, or are they requesting pottery up there that is different to the south for whatever reason? So whether that's cultural thing or whether it's an imitation, we're not quite sure. And also in terms of the colour is very interesting as well, because at Archaeological we have the all red rouletted ware. So you get the all black and the black and red, but we also get an all red version, Archaeological, which is very, very interesting, and we don't fully understand it. We do get all red at other places, but there's a huge amount of pure all red rouletted ware at Archaeological that was originally thought to be some kind of African slipped ware, but it's not. It is, Begley has confirmed that it is actually just a red variant of rouletted ware, and that seems to be slightly later than the black and red rouletted ware. So there is potentially a change in fashion, over time, where there is a preference colours over time. So that could be happening at Archaeological. It may also suggest we have local production of the all red rouletted ware at Archaeological, the fact that it is so prolific there. And so that might be of some significance as well. So certainly those variations in designs and colours are significant, but we don't fully understand what they mean just yet. Great question, yeah.
Thank you, ma'am. Maybe I was a little curious to know a little more, if you allow me to ask. So you highlighted, ma'am, in your lecture also about the distribution of the rouletted wares in different parts of Gangetic Valley and the South India and other parts of Southeast Asia. And you also pointed out that there is possibly a single source for of South Asian origin of the rouletted ware. So, is there? How do you see the trade of rouletted ware over the larger circulation network of South Asia? And do you find any pattern in the distribution or in the circulation of rouletted wares over South Asia in different regions in ancient India?
Sorry, what do you mean? Where
Uh,
where
is
it
there
came
any
from? You mean?
is there any pattern in the circulation of the rouletted wares over the trade networks of whether it is regional or trans-regional trade networks?
So in terms of trade networks, so yeah, we do have this huge distribution. If you remember the map, all the way into Southeast Asia and Indonesia, and also west over to Egypt. So there's a huge distribution. And so we're looking specifically, the finer variety does appear to be very, very similar geochemically. Now, where that source is, we know it's somewhere in South Asia, partly because of the dating evidence and partly because of the geology does seem to conform with the geology of South Asia. So we know it's South Asian in origin, but it has this huge distribution network. So it's obviously very, very much involved with the Indian Ocean trade network, so both going east and also going west. And certainly South India and Sri Lanka play a huge role in that distribution because obviously down in the south, they can take advantage of the monsoon winds that enable you to travel directly east and directly west. So certainly we know that distribution, we're not quite sure of where the pottery was produced, but certainly in terms of distribution, it is likely to have been transported from South India and Sri Lanka, from those sites, particularly when you think of Patnam, where we have 13,000 sherds. It is highly likely that pottery was distributed from that area going west, so goes to places like Oman and Egypt and places, and also from Maharama. So Pavan and Shank have done a lot of research looking at ceramic assemblages from Maharama and Korori, or otherwise known as Sumharam, in Oman, and there are lots of similarities, not just in terms of fine wares, but also coarse Indian wares that have come up in Sumharam. So that shows there is a clear link there between Sri Lanka and Oman. And then also to the east, with the monsoon aiding the transport, and it's obviously a lot closer to go from Sri Lanka to South India over to, say, island Southeast Asia, such as Bali and Malaysia. It is a lot closer than, say, from North India. So we are seeing these patterns of distribution, and we have found not just rouletted ware in Indonesia and Malaysian places, but we're finding Archaeological type 18, which is incredibly rare. But we have Archaeological type 18 in Malaysia, also in the burials as well, in Bali. Also Archaeological type 20 in Bali as well. And sites in Thailand like Kampong Chao and Bukau Tong have also got knobbed ware as well as rouletted ware. So we're seeing not just rouletted ware, but the other fine grade pottery cropping up here and there. The odd bird you might see, but it's clearly being transported as part of the Indian Ocean network, whether it's from merchants travelling and are carrying it with them, or whether we're actually seeing craftspeople moving to these countries and actually putting some pottery over there. That's one option. Certainly, looking at Berenike, for example, where Berenike and suggested that an Indian community actually resided at Berenike, again, not just because of the fine grade pottery, but again because of the local, the more common wares, the coarse wares have also been found there, like cooking pots, the handy type ceramics. So they've also been found in Egypt, which suggests that a community was living there. Now, whether that was a community of potters or a community of traders or merchants, we don't know. Um, but there's clearly obviously movement of goods, but there's also movement of people as well. And these Indian traders and merchants or artisans were travelling extensively across the Indian Ocean. So not just within South Asia itself, which also within Sri Lanka and South India, North India, but also then East Thailand, Malaysia, Indonesia, and then obviously west to India and Egypt. So huge areas of land and sea being travelled at such an early period as well. Hugely fascinating. Did that answer your question?
Yes, ma'am. Thank you, ma'am.
Okay.
At the end of this session, our young scholars and participants who have joined this session, they are so much curious to know more about Rouletted Ware.
Mm-hmm.
In fact, we have received one more question, if you allow me to take this last question. Um, we have this question from Guru Prasad Arvind Rajendiran. He's asking, what is the purpose of reduction and oxidation firing process? Was there any particular use of pottery made from reduction process and pottery made from oxidation process?
Okay, so if you want to fire pottery in a reducing condition, okay, so that's without any oxygen, you will produce black pottery. If you want to produce red pottery, you need to allow oxygen, so that's why it's oxidization, oxidizing conditions. So you need that oxygen uh, to create the red colour. And then obviously we also see the inverted firing technique that we see with black and red ware, where we have both black and red. So where you have to cover part of the pot with something. So dung ash is a really good technique to cover part of the pot to make it reducing. I don't think there's any particular function that I'm aware of as to why you particularly want it um, black or red, either reduced or oxidized. I think that's more to do with cultural preferences. There's perhaps some kind of significance associated with the black colour and the red colour and also the inverted colour. I think that is something that I don't think we'll ever really fully understand because that depends on the cultural context. And I think there will be a significance in those colours, but I don't know what that significance is. So, for example, the change to the all red wares at Alakan, there's some reason for that, and it's some cultural reason, and there's certain some preference for all black. So, for example, northern black polished ware, which actually does come in a variety of colours. It's not always just black, but I suspect that variation is more due to lack of control in the firing. So they were intending to make black pottery, but something went wrong and not all the pots turned black. But there was clearly a preference for black pottery from at least 800 BCE. And we know that, and that continued then with fine grey pottery and this huge preference for black pottery. We do see a preference for this black pottery at Anuradhapura with the rouletted ware. That does tend to be all black, although we do get inverted as well. And I think Hydra and Shrink's work at Maharama, she's also noticed colour differences over time as well, with a change from black to red later on. So there is clearly change in ideology somehow that black goes out of fashion for whatever reason. Maybe they just want to change. Who knows? Or perhaps changing the technology and the firing technology and realizing we're not quite sure why, but there does appear to be some kind of change in the colours. Yes, but I think it's more cultural rather. Okay.
Thank you, ma'am. Thank you, ma'am, for the very interesting lecture and for responding to all the questions. Now, at the end of this session, let me convey my vote of thanks to everyone present here. First of all, on behalf of Heritage Society and on behalf of me, and on behalf of all the people who were who participated in this webinar, I convey my profound gratitude and thanks to Dr. Louise Ford, who joined us today in our evening session of this Virasat Talk program. Thank you so much, ma'am, for taking out time and joining us today and sharing your research, and your insights on this whole set of this great topic on Rouletted Wares. I would also like to thank everyone, thank to all the audience, our followers, and especially to our participants who joined us today for their continuous engagement with us and for supporting all our academic endeavors. Thanks to all the participants who asked the questions today for your very interesting questions. I also thank our chairman, sir, Director General, Dr. Anantastosh Dwivedi, sir, Secretary Srimati Manita Pandey, ma'am, and all the directors of different departments of Heritage Society and staffs and officer of Heritage Society for organizing such lecture series and for inviting great people from the discipline and organizing such a lecture series for all the heritage lovers like us. So thank you all of them. Thank you all the Virasat Mitra and all our followers on YouTube, Facebook, and different social medias for staying with us during the whole session. I request all of you to stay tuned with Heritage Society for many more lectures in the coming futures in our weekly talk program. So once again, thank you everyone. Have a great day and good night to everyone. Thank you, ma'am.
Thank you very much. Thank you, Azad. Thank you. Goodbye.